Lesson 3 is working with trig ratios. Only it's not just working with the trig ratios of degree measurements. We're going to be working with trig ratios looking at radian measurements. Okay? So if we do a review from what we did in grade 10 primarily, we have our primary trig functions, sine, cosine, and tangent. Do you guys remember what the sine ratio stated? Sine theta was equal to what? Pardon?
Opposite over hypotenuse.
The opposite side over the hypotenuse. And what was cosine related to?
Adjacent over hypotenuse.
Yeah. And tangent?
Opposite over adjacent.
And what was the acronym that we used to remember this?
SOHCAHTOA.
SOHCAHTOA. Okay? So these trig ratios are not given to you. You are expected to remember opposite over adjacent, opposite over hypotenuse, and adjacent over hypotenuse. What we introduce is, in addition to the 3 primary trig functions, there are reciprocal trig functions, which ask the question, what happens if instead of going opposite over hypotenuse, I went hypotenuse over opposite? What I get is I get the cosecant. So the cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now, cotangent and tangent tend to go hand in hand because they've both got the word tangent in it. The confusing part could be, well, which one is opposite cosine? Is it secant or cosecant? The clue that what they give in here is that each pair only has one co. So cotangent and tangent, secant and cosine, cosecant and sine. So there's only one co in each pair. These 3 trig functions are on your formula sheet. If you look at that yellow one that I had photocopied for you, they are on it right up at the top. Okay? So the first thing that we're going to do is we're going to we are going to relook or revisit the the trig functions, only instead of talking in terms of the opposite and the adjacent and the hypotenuse sides, we're going to create this triangle in quadrant 1. Okay? So if I draw this triangle, the base of the triangle is the length of x. So however many x units. The height of my triangle is y units because it would correspond to the y-axis. And then the radius would be this diagonal length. If I kept going around, I would create this circle. So that's how we get the x, the y, and the r. So if this is my angle theta, and I'm looking at sine being opposite over hypotenuse, what would be my letters that I would be using? Instead of opposite over hypotenuse, what's my opposite side?
Y over R.
Good. So what's cosine?
X over R.
Tangent?
Y over X.
Okay. And then cosecant, which is the reciprocal of sine, would be what? What happens if I reciprocate sine? What do I get? R over Y. Because to reciprocate means to flip it around. So what would secant be?
R over X.
And cotangent?
X over Y.
Good. Okay. Now it says that you should memorize these formulas. You don't need to memorize these formulas. It follows SOHCAHTOA. You need to be able to draw the triangle. If I can draw the triangle, I can figure it out that this sine is y over r. I don't need to memorize it. Okay? So now let's look at the different quadrants. If I look in quadrant number 1, both my y and my r values are going to be positive, which means my sine value is going to be positive. Cosine x over r. What can you tell me about the x coordinate? Is it positive or is it negative? Positive. And my r value is actually always going to be positive. Because how would I get r given y and x? What would I do?
Y squared plus x squared and square root.
Yeah, so it'd be using Pythagoras theorem. So when I square root this, I would always get a positive answer. Okay? So positive divided by a positive gives me a positive answer. And then tan being y over x, they're both positive, and I get another positive answer. I want you to repeat this pattern throughout the next 3 quadrants. So if I look at this second quadrant, first of all, what can you tell me about the value of x in the second quadrant?
It's negative.
It's negative. So I have a negative x, and I have, is my y value positive or negative?
Positive.
Positive. Okay? So use that to complete the next 3 quadrants. So if we fill these in rather quickly, we have sine would be a y over r, which would be a positive over positive, and I get a positive answer. Cosine would be a negative over a positive, which would give me a negative answer. And tangent would give me a negative answer. In the third quadrant, both my x and my y values would be negative. So of my 3 trig functions, which ones are negative values?
First 2, and then 10 is
Because tan gives me a negative over a negative, and the other 2 give me a negative over a positive because of that r value. And then in the fourth quadrant, x is positive, y is negative. So is sine positive or negative?
negative.
Negative, because it's the y over r, so it's a negative over a positive. Cosine is
Positive.
positive, because it's x over r. And tangent is
Negative.
negative, because I have a negative over a positive. Okay. So if we complete the following, the fill in the blank that's below, sine ratios and cosecant ratios, because they are corresponding to each other, in which quadrants is sine positive?
1 and 2.
1 and 2. Which quadrants is cosine positive?
1 and 4.
1 and 4. And tangent is positive in quadrants?
1 and 3.
Okay. Which quadrants is sine negative?
3 and 4.
What about cosine?
2 and 3.
And tangent?
2 and 4.
What can you tell me about quadrant 1?
They're all positive in quadrant 1.
They're all positive. What about quadrant 2?
Sine is positive. And
Okay.
the rest are negative.
So they're all positive in quadrant 1. Sine's positive in quadrant 2. What about quadrant 3?
10.
And quadrant 4?
Cos.
Cos. So if I was to just take the first letter of my all, sine, tangent, and cosine, I end up with this, which I can use as 2 different acronyms. I can start in this quadrant, add sugar to coffee. Or I can start down here, and what word do I spell?
Cast.
Cast. So sometimes you'll hear students that have gone through the course before talk about the cast rule. The cast rule is which quadrant is which trig ratio positive in. which again is something that you can memorize because it is useful. But even if you didn't memorize it, how long would it take you to figure out that cos is negative down here? Would it take hours? Would it take minutes? Probably. So it makes it quicker, but it's not a necessity. So the bottom of the page just talks about the cast rule. Why this doesn't want to move, but we'll just move it up. So the cast rule, or remembering to add sugar to coffee. So determine without using technology whether or not the following trig ratios are positive or negative. So in order to figure out if sine 280 degrees is positive or negative, what would I want to find out about 280 degrees?
What quadrant it's in?
So what quadrant am I in?
4.
Sorry, Rachel?
4.
Quadrant 4. Is that 270 degrees? So according to, if I looked at my cast rule, the only trig function that is positive in quadrant 4 is cosine. So sine would have to be negative. Because I'm in quadrant 4, so I am negative. Okay. Let's skip to D and F because they deal with degrees, and then we'll go back and look at the radian measurements. So if I look at cosecant, first of all, what's the reciprocal of cosecant? Sine. So I'm looking again, if I'm looking at my cast rule, I'm looking for the sine. Negative 225 degrees, what way is my angle rotating?
Clockwise?
Clockwise. So I've got 90, 180, so 225 is going to put me in what quadrant?
3.
Pardon?
2.
2. Quadrant 2. And what is sine in quadrant 2?
Positive.
Positive. So cosecant would also be positive. And then in F, I have secant, which is the reciprocal of cosine. So then 1,000 degrees. If I go around once, how many degrees do I have?
360.
Go around twice, I'm at
720.
okay, and then another 90 gives me 810. Then I've got 900, 990. So what quadrant does that put me in? The 4th quadrant. So quadrant 4, and what is cosine in quadrant 4?
Positive.
Positive, good. Now let's look at these radian measurements. 7 pi over 6. How do I graph that?
You split each, like the top side into 6.
So each half gets split into 6. Why is it a half? What is this? If this is 0 radians, what's this over here? Pi radians. So if I have a pi, or if I have 6, then that's 1, 2, 3, 4, 5, 6. There's 7. What quadrant am I in? Quadrant 3. And in quadrant 3, what is tan? Positive. Okay. How do I graph 10 pi over 3? What do I split the top into? Into 3. So 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10. So I go around once, and then I end up in quadrant, which quadrant is that?
3.
3. And what is cosine in quadrant 3?
Negative.
Good. And finally in E I have cotangent. What is the reciprocal of cotangent?
Tan.
Tan. A negative 13 pi over 6, which means I go in which direction?
Clockwise?
Clockwise. And the 6 tells me I divide everything into sixths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it means I go around one full rotation, I get to 12, and then one more. There's my 13, or negative 13, sorry. What quadrant does that place me in?
4.
Quadrant 4. And what is tangent in quadrant 4? Negative. Good job. Okay. So now, calculators have the ability to calculate trig ratios in radian mode and in degree mode. So if you were to grab your calculator and turn it on, and press the mode button, there's your radian and degree. By default, when your calculators are reset, they default into radian mode. So if you've had your calculator recently reset for a test or a quiz, you would be in radian mode. If I asked you to calculate the cosine of a 30-degree angle, you would need to change into degree mode. If I just put in sine 30, then I'm calculating 30 radians, which is not the same as 30 degrees. Okay? When I am calculating the reciprocal trig ratios, we need to use the reciprocal of the corresponding primary ratio. So for example, if I want to calculate the value of cosecant 5 pi over 6, I have to be in radian mode, and then I can do this one of two ways. I can go 1 divided by sine 5 pi over 6, or I can find out the value of sine 5 pi over 6 and then go 1 divided by that value. Okay, so whichever system works best for you. So what I want you guys to try to do on your own is these 7 questions to 4 decimal places. So what is sine 280 degrees?
Negative 9 or 0.9848.
How many of you skipped and did E and G before you did the next ones? Just so you didn't have to move your calculator back and forth. Why not this one?
Because it's radian, because it doesn't have the degrees.
Good. No degree symbol means it's in radian mode. So how do I, first of all, what is cosecant negative 225 degrees?
I did sine negative 225 and then 1 divided by that value.
Okay. So 1 divided by sine negative 225. And what did you get?
1.4142.
Okay. And what about secant 1000? How did you do that one?
1 divided by cos 1000.
And what did you get?
5.7588.
Good. And then from here you can switch your calculator into radian mode to do the next 4. So what is tan 7 pi over 6?
0.5774.
Cos 10 pi over 3?
Negative 0.5.
Sine 90. Okay, so then sine 90 0.8940. Does that one work for you, Jessica? The sine 90?
No, I got 1 for that.
Okay, and then cotangent. So this one, it would be 1 divided by tangent, negative 13 pi divided by 6. And I should get an answer of negative 1.7321. Okay, so just make sure that you are in the correct mode. Okay? The next part is just looking at expressing a trig function in terms of a reference angle. So trig ratios for any angles are either the trig ratio of the reference angle or the negative trig ratio of the reference angle. So I'm going to look at an example and then we will go through the method. So if I look at cos 7 pi over 4, what I want to do is I want to graph this out. So I want to see where 7 pi over 4 actually is. Okay? So the 4 tells me I split the top into 4 pieces. So 1, 2, 3, 4. I would do the same to the bottom. So 7 pi over 4 puts me down here, which is in which quadrant? Quadrant 4. Okay? What's my reference angle going to be? So what's this measurement right here? Pi over 4. So my reference angle is pi over 4. And in quadrant 4, what is the sign of cos? Positive. So what I'm going to type into the calculator is I'm actually going to, what this is going to equal is it's going to equal the same as cos pi over 4. And I can check that with my calculator. I make sure that I'm in radian mode. If I type in cos 7 pi over 4, and then I type in cos pi over 4, I get the same value. So now if we look at, I want to skip and I want to go to C, 11 pi over 4. Or sorry, 11 pi over 2. So 11 pi over 2 means that I'm only splitting this in half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it means that I go around 2 3/4 times. And that's going to be my 11 over 2. So this puts me right in the middle. And it kind of puts me between quadrants 3 and 4. What's the value of sine in quadrants 3 and 4? Negative. And then my reference angle, again, is that measurement from the terminal arm to the x-axis. So what is the measurement of this angle?
90 degrees.
90 degrees. What would it be in radians? Pi over 2. So sine 11 pi over 2 is the same as sine pi over 2, but because it's in quadrant 3 and 4, it has to be negative. And again, I can double check that. So then if we look at B, I have to be in degree mode if I was to be using my calculator for this. Negative 100 degrees means that I am going clockwise. And what quadrant would I end up in? Pardon?
3.
Quadrant 3. So I'm in quadrant 3. What is the value of, or sorry, what's the reciprocal of cotangent? Tangent. And what value is tangent in the third quadrant? Positive. And what would my reference angle be?
80 degrees.
Good. So then cotangent negative 100 degrees would be the same as tangent 80 degrees. Okay, we're almost
1 over?
Sorry, not tangent 80 degrees, cotangent 80 degrees.
Oh, okay.
Sorry. Which then would be 1 over tangent 80 degrees, yes. Okay. Suppose I have the point 15 and 8, negative 15 and 8. It's a point on the terminal arm of this rotational angle. If I drop this point down to the x-axis, what shape have I created?
Right triangle.
A right triangle. What is the base of my right triangle?
Negative x.
Which in this case is negative,
Both 15.
okay. What's the height of my triangle?
8.
How do I find out r?
Pythagoras theorem.
Pythagoras theorem. So r is going to equal negative 15 squared plus 8 squared. I take the square root of that. What does the question ask me to find? Calculate the exact length. So when I put that in my calculator, do I get an exact answer? 17, okay. If I didn't, what I might want to do is just figure this part out underneath first. Okay, so here's my 17. So using these three values, that's my rotational angle theta. And my rotational angle theta is actually going to give me, so if I'm trying to find the sine of theta, it's going to give me the same thing as finding this part here for sine. So if I'm calculating sine theta, which is opposite over hypotenuse, I would have 8 over 17. So following that pattern, what would cosine be?
Negative 15 over 17.
What would tangent be? Fun that you like that.
8 over negative 15.
Okay. And I wouldn't put the negative on the bottom, I would bring it out to the front. What's the reciprocal to sine? Cosecant. So what would cosecant is CSC. So cosecant is the reciprocal of sine, which would make it
17 over 8.
the reciprocal to cos, which is SEC. And the reciprocal of that would be
Negative 17 over 15.
good. And the reciprocal to tan is
Cotangent.
which would be Hannah? Good. Okay, one last part. Cotangent A equals the square root of 3 divided by 2. And sine A is negative. Complete the following procedure to determine the exact value with rational denominators for cosecant and secant. If cotangent is positive, that means what else is positive? Pardon? Tan is also positive, okay? And according to my cast rule, in which quadrant is tan positive and sine negative? quadrant 3. So that tells me that this angle A has to be in quadrant 3, because that's the only quadrant where cotangent or tangent is positive and sine is negative. Cotangent is the ratio x over y. It's the reciprocal of tangent. Which means if I have root 5 over 2, sorry, not root 3 over 2, root 5 over 2, root 5 would be x, and 2 would be y. In quadrant 3, both of these values would then have to be negative. So if I was to draw this out, this point is in quadrant 3, and then my reference triangle would look like this. So this point is negative root 5 and negative 2. So negative root 5 would be my x, negative 2 would be my y. So then if I use Pythagoras' theorem to solve for my r squared would equal negative root 5 squared plus negative 2 squared. What is negative root 5 squared? What happens when I square a square root? Cancels each other out. And the negative would end up becoming positive because it's squared. So I get 5 plus 4, which is 9. And so then r would equal 3. So then we're going to write cosecant and secant. So cosecant is 1 divided by sine. What's sine? What's my ratio for sine?
Opposite over hypotenuse, so
Opposite is,
negative 2,
and hypotenuse is
3.
3. 1 divided by that would be to reciprocate it, so I would get 3 over 2, or negative 3 over 2. And then secant is 1 divided by cos. What's cos?
Negative root 5 over 3.
So then I would get 3 over negative 3 over root 5. What if I couldn't have the root 5 on the bottom because it's a irrational number? What if you were asked to rationalize it? You remember how to rationalize the denominator?
2 times the top and the bottom by root 5.
Okay. So I understand why I would multiply the bottom by root 5 because I already showed over here if I multiply it by itself, which is the same as squaring it, I end up with 5. Why do I multiply the top by root 5?
So you're multiplying it by 1, which doesn't change the value.
Good job. So then I get negative 3 root 5 over 5. Okay, so here are your questions. 2, B, C, and F